So anyways, I'm gonna start with chapter 9, and then we'll talk about the plans for next weeks until the end of semester. So I'm waiting to see if you have any questions, because we started to make point plots in totally different system of coordinates and so-called polar coordinates. Let me start with making a picture of something that will give you a good flavor of what this differs with, and this be exercise 37. So this is dealing with where r is equal to -3. And since it's negative, it's kind of hard to say it's radius, but distance from the pole and polar coordinates. Excuse me. And pi over 4 with negative sign is angle theta. So the way we always start graphing in this system is we put a pole, has 0 in it, and then radius r. Then I go by the angle theta, which is going to be 45 degrees with negative sign, so it'd be negative pi over 4, which is same as 45 degrees. You say, Alex, how do you remember? Well, at the end of the textbook, there is a circle, and it shows a relationship with these pi is 180, pi over 4 is a quarter of 180, which is 45. So we can always double check. So the point called R should be on this angle, but since it's negative, so it could be somewhere 3 steps from the pole, but now it's going to be in the opposite direction, because negative means we go the opposite way. So the point we end up with is here, and it is where -3 and minus pi over 4, and it's not x and y, it's r and it's theta, and that's what we actually see. Oh, I see 2 people in class. That's perfect. I will, of course, make a note of this. This is very, very good. And I already started to discuss last time how this could be rewarded. And let me know if you disagree with that. I'm open for other ideas, but I'm glad that you are here, and we'll discuss this a little later. Let me make some more pictures. So they wanted to plot the point. I did. I plot the point. It is right there. If you want corresponding x and y coordinates, you can always recall that x is r. That's not what problem says, but you can always convert this to x coordinate and to y coordinate using the standard r cosine for x and r sine for y, which is actually good to be aware of, because sometimes you need that. And r is -3, and cosine of theta is cosine of -pi over 4, which is square root 2 over 2, so it'll be -3 times square root 2 over 2. And it looks like exact same thing will be with the other coordinate. I think I should have used the other color. You better see this. So if you use -3 for r and -pi over 4 for theta, you're going to end up with -3 times, notice that sine and cosine of 5/4 as square root 2/2, but I should be a little bit more careful because cosine is positive, right? Because that's x coordinate, but sine will be negative. So we're going to end up with multiplying two negatives and end up with a positive. And that's our y coordinate, which you could probably see will be positive, and x coordinate will be negative. Right? If you can get corresponding xy plane, but that's not what they asked me about. So they're just giving you a little bit of a hint in here. So the idea is if you have pair r and theta, you can always convert it to pair x and y. In fact, I can find an exercise that asks for that. And that could be interesting. Find polar coordinates. So it looks like at the end of this section, this kind of exercises appear. So they say if you have rectangular coordinates, get polar coordinates, and there should be some backwards procedures as well. So if you have rectangular, get polar coordinates, actually, let me do this. Number 67. The reason for this convergence, as usual, has an idea that you are good at graphing an XY plane. And if you're given such an exercise with 2x squared plus 2y squared is equal to 3, then you could probably turn this into equation in polar coordinates r and theta, simply using these two identities. So instead of x, you're going to put r cosine. So it's always the same. The thing is, you just replace r cosine of theta. And instead of y, you're going to have r times sine of theta. It's always like that. And of course, in this equation, we have 2, and this thing is squared, right? Plus also 2, and that thing is squared. And 3 is on the other side. So what can I do to simplify? Well, Pythagorean theorem, remember, it's always with us. Sine squared plus cosine squared is equal to 1 squared. X squared plus y squared, and that's sine squared and cosine squared, right? So we get square of hypotenuse. So it looks like we got 2r squared times square of cosine, and also 2r squared times square of sine is equal to 3. So what I want to do is factor out, oh, somebody just sent me homework, that's great. So I'm going to factor out 2r squares and now square of cosine plus square of sine, my favorite little formula, which is going to be replaced with 1, right? So we're going to end up with just 2r squared times 1, which is nothing but same 2r squared, right, is equal to 3. In other words, r squared is equal to 3/2, and I can go one step further and say that, maybe I'll get a little bit of room here, that R, so what about R? What is it equal to? Well, looks like it'd be a square root, right? From this story. So we get a R then equal to square root from 3/2. But since it's extracted, it could be plus or minus. How can I graph this in polar coordinates? The radius is square root 3/2. So I put square root 3/2 here and get a circle of radius that number. Say, wait a second, why is that? Well, because theta is not given. They don't tell me what theta is. Remember, there's always r and theta. So if we have just radius and theta could be anything, so theta could be pi/2, that'd be the point. Could be 0, that's the point. Could be pi/4, like in the previous example. Could be any angle. So whenever it's any angle, then we can just go around the center. And this is nice way to produce equation of a circle. In fact, some people that took class called college algebra probably recognized that if you divide this by 2 on both sides, you get x squared plus y squared is equal to square root from 3/2 squared. So that's equation of the circle. So we also encounter this when take some math classes, college algebra class, and it's a polar way to actually describe the same thing. How about that? And it's much nicer equation. It's just r instead of x squared, y squared. And that's the idea, that we have nice description when something is in the circular format. That's pretty interesting. So we can do graphing here. So I guess this section is dealing with manipulating on those two formulas. So how I manipulate? Well, whenever I see x, I replace it with r cosine. I see y, I replace it with r sine. I know it's a little bit unusual, and that's why I don't think I want to test you on this kind of stuff for the final exam. It'd be probably too much. But in the meantime, I'd like to discuss this a little bit. In fact, there is some graphing that they discuss in the next section that I want to just introduce to you. For example, graphing of linear equation. Please notice that equation we have here is actually the line theta is equal to pi/4. Really? Well, angle theta is pi/4, means that r could be any number. So distance from the pole could be 1, could be 2, could be -1. Remember, it goes in the opposite direction. -2 could be 1/2. So notice they're all on the same line that makes angle of 45 degrees with this positive direction. So we have our self-equation of line. How about that? That's just amazing. So they also show you how you could convert it to the old favorite equation with x and y. So it looks like this would be like y is equal to x plus 1. So x plus 0, actually, right? So the point of intersection with y-axis is origin, so 0, right? Because nothing is added, and the slope is 1. And what they're saying here is that if you convert this to the following by attaching tangent on both sides, taking tangents on both sides, you're going to get tangent of theta on one side is tangent of pi over 4, which is 1. If you don't remember, you can put in the calculator. And what's tangent of theta? Well, if you recall the idea of description of angle, let's say here, theta, hope you see, maybe I better write it bigger, it's kind of too small. So if your angle here is theta, then remember x coordinate is called cosine. We are on the unit circle. And y coordinate is called sine. That's definition of sine and cosine. I hope you did not forget it by now. And what about tangent? Isn't that sine over cosine? Right? And sine over cosine in terms of x and y, cosine is denominator, x, and sine is y. So whenever you have y over x, that's going to be a tangent. So that's why they're actually using this trick. In fact, we have two formulas that convert backwards, turns out. Tangent theta is 1 over x, and x squared plus y squared is equal to 1. So these two formulas, we're familiar with the second, but the first is just coming right out of definition of sine and cosine. They're analogous to the ones we had here that we just used, that having r and theta convert to x and y, but they go backwards. So if you have x and y, divide y by x, you get tangent, and add their squares, you get 1. So that's another possibility. Actually, I would say that's r squared. They don't have to be always from the unit circle. You can have x and y, various other numbers. So x squared plus y squared is r squared, square of hypotenuse. So these two formulas convert backwards, and turns out that you can actually do backwards conversions, like exercises I just saw in the previous section. I didn't do it. I wanted to show you the formulas first. So now I think we're ready. They're saying that if you have the polar coordinates produce the rectangular coordinates. So polar coordinates, you get rectangular coordinates right away. How can you produce backwards polar coordinates? Find the polar. We have problems in here. So try 61. 60. I'm in the section 1 of chapter 9, the one we started last time. So if you have square root 3 for x and 1 for y. So what's important is to realize what you're given. So you're given x and y. So how can I get theta and r? Well, just put them in the formula and you will get your r and theta. So tangent of theta will be y over x. So you divide 1 by square root of 3. And you probably are familiar with that angle, it's 30 degrees, I think. And then x squared, which is root of 3 squared plus 1 squared, which is just 1 squared, is r squared. So what about r? Well, extract the square root from this. So it'll be 3 plus 1, which is 4, right? Square root 4 equals to 2, isn't it? So angle theta is 30 degrees, or pi over 6, and r is 2. So you actually have pair r theta that, again, has absolutely nothing to do with these two numbers, right? That's why I'm saying that it's not really possible find relationship with the rectangular and polar description of the points. You say, Alex, how do you know it was pi over 6? Well, you could use a calculator, so you could have applied tangents to both sides. Remember, if you want to get rid of trig function, you use inverse on both sides. Try to squeeze inverse tangent here. And then put this in a calculator. So you're going to get a theta, which is equal to find arctangent of 1 over square root 3. Let me show you that. I guess that's the fastest way. So my favorite scientific, right? And I need arctangent function, which is not here. So I go to functional menu, and here's arctangent. Remember, back to main, I need to enter what? 1 over square root of 3, right? So by square root 3, but degrees would be a better idea, because otherwise with radians you won't be able to see it. But with degrees you get 30 degrees. Notice radians is not clear. Always put degrees, 30, and that's what we have. Pi over 6, 180 over 6 is 30. So if you feel not very comfortable with this at the point, well, maybe you can skip the final. Remember, I offered the following, and you can think about it and let me know by next class meeting if you are okay with your grade up to date. I will let you keep it, but you need to turn in your homework. So you need to turn in your homework to retain your grade, and you don't need to take the final. Check your course grade on Canvas. You know how to do this, right? Get a computer. Don't have to buy it. Just go to any computer and log in and get your Canvas open, or ask me. I can tell you if you're not sure. It didn't change since after the midterm. So I entered those grades, the course grades, and they still there. So if you like that grade, in fact, if you have an A, well, then I guess you cannot improve it. It's going to be same grade. So you probably don't have to take the final. You can just turn in your homework. And those of you that were in class, in person, in class, I'll let you not to turn in homework. So you'll just get that grade. Just be there in class next time, and that's good enough, right? So if you're attending, I can see same people keep coming, and that's great. So I'll let you do that. I already told that, by the way, last time. So you decide if you wanna improve your grade. Say you got a B and you want to get an A. Well, then take the final. I'm going to email you a practice for the final later today after class. And I will discuss it on Thursday, the next class meeting. And then after, as I promised, at the end of the day on Thursday, I will send the actual final to those students that want to take it. So if you don't want to take it, email me. Tell me, Alex, I don't want to take it. I'm fine with my grade, whatever. I'm also fine. But if you want to take the final, for whatever reason, you still have a perfect grade, but you want to take the final, fine. Don't send me anything. I will email you the final and I will grade it for you, of course. And I will grade it when it's due. So I'm not going to grade it right away. Our final, according to syllabus, is going to be Tuesday, not next week, but after the Thanksgiving. So that'd be December 3, I believe, for the final. So that'd be the day if it's due. So if you don't take the final, you will get the grade, which is on Canvas. It's called course grade. Check the Canvas. If grade is C, then it be C. If grade is A, then it be A. But I need your homework. So the homework is due on the day of the final. On the day of the final, we'll have homework. What did I ask you to do for homework? Well, just do one problem from each lecture. I was sending you those lectures by email. I know that some of those lectures disappeared because they keep them only for 30 days on Zoom while our college is trying to save the money. And all of those lectures I also posted on YouTube channel, remember? Just to refresh your memories. So yeah, you don't have to take the final. Just let me know that you don't want to take it. So your grade will stay the same as on Canvas. I'm just repeating it again, make sure everybody can get that. So stays the same with course grade. So check your course grade, but someone told me they tried to check and it says completed. Well, use computer to check your course grade because cell phones sometimes don't tell you correct grade. So go to the computer, to laptop, desktop, whatever, and open your Canvas and see what your course grade is. I don't put word final grade because final grade is grade for the final exam. So that's not really the grade you get for the course. Course grade. It is on Canvas. So, but you need to turn in homework. Those students that don't want to take the final. So I want to show you, I go to Canvas and I'll show you how to get to this lecture recordings. I already did that. You just need to open our class on Canvas. So that's Math 135. And in the syllabus, there is a link, remember? So syllabus is right here, if you can see it. Maybe I should clear this mess. So in the syllabus, I can see here the link. I asked you to save this link or whatever, or go to the syllabus on Canvas and, well, you'll have to paste it into the search in a Google search, because I'm not sure if every single search engine will take it, because sometimes they don't, and that's making people to panic. So go on Google and put that link, and it should bring you right to the folder that has to do with our class. Does it? bring you to that folder or not really? Let me clear this. It's annoying. It's too much message. Oh, I know the quick way to do it. I'm gonna stop to share it and then share it again. That's the fast way. So I don't have to erase everything again. So that they mixed it again with some other stuff. See, they offer you to watch some other things. So how can you get there? So you go to math lectures. They always put the links and then so you go to playlists and you select trigonometry. Lost trigonometry. Because we're in trigonometry class. And then you see this entire folder because that folder is always being lost. So if you scroll down, you will see the midterm. So after the midterm is lecture 13. So you have 14, then 15, they got mixed up a little bit. Then 16, 17, and so forth, all the way to 24. I know there is a 25, but I got rid of it because it wasn't correct class. So I got rid of one. So up to 24. 24 is the last. So you can see there is a last one that has to do with 24 with law of cosines. So basically chapter 9 is not even included here. So you don't have to worry about it, as I said. So last is our law of cosines here. So remember with the law of sines, law of cosines. So you can do any problem you like. So one exercise, here's the exercise 18, for example. Or if you like, there is some other exercise and go further, so you can probably find the other. So one exercise for each lecture, does it? Maybe 18. Here's we'll do new one. So if I try lecture 21, you will see that I done like 14, I done 35. If you go further, you can see I done another exercise here. Did I? Well, anyways, you can look a little deeper than that and you will see there's some exercise. So do just one. You don't have to do a lot. For homework, just do one problem from every lecture recording. If you already did it from those previous lectures that I emailed to you, perfect. Just send me all that by email. The way you did was midterm. People sent me perfect homework for the midterm. Everyone got full credit, whoever sent it to. There is still a couple of students that never did it. So those students should send me their work so they get their credit. So one problem from each of those starting on after the midterm. So that's midterm was 13, so lecture 14. 14, one from 15, one from 16. So I don't think it's a lot because probably going to take you how many problems? 14 through 24, so that's 11 lecture recordings, so 11 problems. How about it's not a lot, right? 11 problems. And you will retain your grade, the grade that you have as a course grade. And if you want to raise that grade, or if you want to try yourself, say, you know what, Alex, I have an A, but I still want to take the final. That's fine with me. I will also email you the final. I will also grade it for you. Okay, that's absolutely fine. So think about this. And by Thursday, let me know if I should email you the final or not. If I don't get your email, I will email you the final and you will have plenty of time. Again, it's scheduled for December the 3rd, right? So it'll be Tuesday, December 3. But you may do it over weekend and send it to me by email on Saturday, Sunday, or Monday. So you will have the whole Thanksgiving week for yourself to celebrate and to maybe prepare for your other classes. But I will still be grading it on December the 3rd, actually December the 4th. So by following Thursday, I will put your final grade on Canvas. So you will know what you got in Canvas. So final, I will send the final this coming Thursday. I think somebody was asking me to send it Thursday. So I promised already. So I will send it on Thursday. And again, I will send it by email to everyone who wants to take it. So if you don't want to take it, let me know. If you don't let me know, I will send you the final. And then you can always decide, right? So I'm trying to be flexible on that, but I'm fine grading your exam, even if you don't want to take it. That's fine. You may receive it and say, Alex, you know what? I changed my mind. I don't want to take it. I'm fine with my course grade. Okay. Do not just leave you course grade. Just make sure you please send me your homework. This is referring to everyone except for those people that are in class. Those people that are in class, I'm giving you a break, guys. Just be in class next time and I'll let you not to even send me homework. I think it's fair. They've been driving all the way to the college, all this, they see every single class meeting. So that's good. That's very impressive. So yeah, and I know that other classes might give you a hard time. I know some instructors give lots of things on the finals week. So you might want to utilize your free time from math to study whatever you take. Physics, there's some classes that you might have to do projects, right? So anyways, so that way you will have more time to succeed on the other classes. And also homework. Yeah, you just, if you're already done with homework, if you did whatever from the lectures or just copied the same problems they did, that's your homework, so you already have it. Just make a picture and send it to you. I'm not asking you to do some more stuff. Just one problem from each of these lectures is fine. And I know these lectures a little bit different because I didn't post those lectures I did this semester from previous year. But it's okay from that lecture, or if you already have from this year lecture, just send me something. That'd be your homework. So you don't need to redo anything. The reason I show this YouTube channel is because if you didn't start your homework as of yet, if you try to find lecture that we have after the midterm, which is going to be lecture 14, the recording is not going to show you anything because more than 30 days already passed. So that's why they don't retain this section 6.3 recordings any longer. If you dig out from your emails, it's probably been sent to you 40 days ago or so. So they disappeared already. See? And that's why for your convenience, I have it here on YouTube. If you're already done problem from each of this lecture, that's it. You don't need to worry about homework from them again. Just go to the end and do problems from the rest. So it is up to you which one to select. That's why I'm saying any problem is fine. You don't have to do the problem that I did during these lectures, like problem 30 or whatever else is here, 43. You can do problem number 31. Maybe problem 31 is what I done in the previous year from that lecture. Okay, so whatever you do, just show me that you practice. That's what I consider as homework. Okay, so any other questions? We have very good questions that I'm sure answer questions that someone may have in mind. But if you still have question in mind, don't hesitate, email me the question. I will be, of course, answering more questions on Thursday, as well as next week on Tuesday. I know next week you will already see the final exam, so you may be done with it, but I'll still go on Zoom on Tuesday next week, as well as on Tuesday week after next, because next week, Thursday, we don't have classes. It's Thanksgiving, right? So I will be on Zoom, of course, and on Tuesday next week, and after next week on Tuesday, December the 3rd, when the final is due, as well as I will be on Zoom on Thursday, December the 5th. Just for in a case if somebody forgot homework or somebody was sick or somebody could not log into Zoom all these days or into email, because final is not mandatory. It's up to you. If you want to take it, I'll be more than happy to grade it. If you like your current course grade, whatever is called course grade, it's on Canvas, it will not affect your course grade, will stay the same. But I need to have homework. You need to send me homework. Well, in any case, you should send me homework. If you take the final, you don't take the final, right? We need homework. So anyways, so Tuesday I will be there, and on Thursday, December the 5th, I also be on Zoom for just in case, because I was about to tell you one important thing. The college done, I think, pretty crazy thing. By the end of semester, I'm not sure if you received their email, they want everybody to change their passwords and to do two-step login. That's what I've been doing all the time. But first time I done it, it was kind of annoying. They want to connect your cell phone with this college email. See, they force you because they don't let you in the Canvas, they don't let you go into email. And I know to some people it's very difficult. I still have students that struggle to get their email, the school email opened. And now they want to change everybody's password. There was a big glitch in the system, so they decided to, and I'm glad that you already changed to it. So in the case if you can't, well, I think you have time till the end of this month, and then on December you won't be able to log in. So what I did, I didn't connect with my cell phone. I use my personal email. So they send the code instead of text message to the cell phone, they send email to me. Oh, you have it till November 25. You see, that's even less time than that. So don't panic. Just in the case if something happens, I will be waiting. I will be patiently waiting. I think we have time. I have to submit grades sometimes by over the weekend. So that's probably going to be December the 10th or something like that. So you will still have plenty of time to do that. But you really need to be able to log into the system, because if you don't change your password, that's it. They'll cut you out. You're probably going to have to go on campus. Well, just go to IT, and you need not to be on Palmdale. You need to go to that main campus where the SSV building is, where the business department is located. It's on the first floor, there's IT. That's where you can get a free laptop device, and there they'll help. But I advise you to use a personal email, so they send your code to get into this AVC system to your email rather than to cell phone, because cell phones sometimes don't work. Remember with Verizon, we had a glitch recently. So that's why I use my Yahoo email for that. But anyways, either way, they want to have some authentication extra step here. And that's the reason why they actually doing it. Look at this. Tangent of what? Pi over 6 is 1 over square root 3. That we just had it somewhere here. No, I erased it. But anyways, that's three values of tangent. That's good to know. So anyways, yeah, I think that should be done before semester start, not before the finals, when everybody's nervous, people are busy, and then they get cut out of their school email and panic, and that's no good. But please don't panic. If anything, you can always email to me from your personal email. It'll go through. Just you need to know my email address, so you should have syllabus, or you can find me in directory, the AVC directory. Just put my name and math department and put word email. They will give you my email, so you can always email me and let me know if something happens. And I always try to help. I will definitely do my best to help you with that. So just contact me whenever you have any questions, because I'll be the first one that you should contact. Okay? Because now I understand that there is some hard time, so I can always give you a little extra time for homework, for submitting your final. In fact, if you send me your final earlier, somebody says next week, fine. I will acknowledge that I received your work. So I will say thank you, or I got it, whatever, so you know that I received it. But I will be grading it when everybody submits it. So probably Tuesday night. And on Wednesday, the following day, I will post grades for the final exam as well as update Canvas. So the following class on Thursday, December the 5th, I will begin on Canvas. If you want to discuss anything, usually people say, Alex, how can I improve? How can I get better? I'm always open for that. So we can discuss that. That's fine. So, or if you say, Alex, what kind of mistake I made, I will show you what mistake you made, and we can again talk how you can fix it, because we'll still have little time, but not much time. So we need to be very careful after December the 3rd. Don't wait till Christmas. We'll have about a week to make up things in the case if needed. Okay. So if you have any other questions, I'm trying to answer whatever questions come up with. Some of them come directly to my name, so you probably don't see it when you check the Zoom chat. That's why you may wonder, what am I talking about? Well, I'm answering questions that I got from this chat. And if you don't have questions, feel free to go check your email after the class ending. I will be sending you a recording of this lecture as well as practice final, unless you decide to opt out from the taking the final. Just shoot me an email or put that in your Zoom chat. Have a good day. Thank you. And I guess we're done with class material. This is great. So it's time to take the final. So I hope everybody's going to enjoy it. Stop sharing this. If you don't have any other questions, feel free to log out. Thank you. Thank you. Bye-bye. Have a good day. Thanks. So I guess I'm gonna end it for today. If there are no other questions, I'm gonna just stop for today. Okay. Thanks for coming. Bye-bye.